Let's talk more about structured streaming, and let's introduce you to this topic. What is structured streaming, and how does Apache Spark implement structured streaming? The thing is that structured streaming is really just a stream processing framework that's built on the Spark SQL engine. Now, I say SQL, you might say SQL. That's just the way I've always said it, is SQL, and so I'll say Spark SQL engine. So we have stream processing framework, a means by which that we can process in a fault-tolerant and scalable way our data streams that might be coming in. Now, this uses existing structured APIs that you may already be familiar with, things like SQL APIs or data frames that you may be already familiar with as well. And these are similar APIs as batch processing to make it so that it's seamless to move from batch processing over to streaming processing in the quickest and most economical and easy way as possible. Now, this also includes stream-specific features, so end-to-end, exactly once processing, and fault tolerance, all implemented within structured streaming and within the Apache Spark structured streaming framework. So how do we then understand how we have a data stream and how can we better visualize this? Let's look at this graphic. We have a data stream that's coming in, and we have maybe specific records that are part of that data stream. We push those records into a table, and they become rows in that table. The thing about this table, though, is it's unbounded, right? We have no endpoint. We don't have a set number of rows. There's a continuous appending to this table, and so the table itself then becomes unbounded, just like the data stream itself has no beginning or end, right? It's just continuously coming in. There's more data coming in all the time. So really, new data from the data stream becomes new rows appended to this unbounded table. How then does structured streaming work? We have an input table that is defined by configuring a streaming read against a specific source, and that source is going to be some table, and a query that's defined against that input table where we seek to pull data from that input table, and then that gives us then a results table that can then be output out of the streaming pipeline and persist that to some specific sink external to the pipeline itself. So new rows are appended to the input table for each trigger, right? So as time continues on here on the x-axis, we have a trigger, for example, every second. We get the data that's currently in there, we run a query, push it to a result table, and then that gets sunk into an output table when it's in complete mode, right? So here's essentially one model for a specific execution mode that's available to you in Spark structured streaming. Here's the anatomy of a streaming query, right? So we have our data sources, maybe it's JSON data or Kafka data. We have a query where we apply some transformations and actions, and then we push that into a storage layer like Delta Lake. And in our case, that's what we want to do because Delta Lake gives us a tremendous wealth of specific features that are going to be available to us. So the idea is now, and we have an input source, right? That's the source data. We have a sink, which is where the data is going to land, transformations and actions, and then we have triggers. And the triggers may be on a schedule, they may be when data arrives, depending on what kind of trigger you're implementing. And here's how we can specify this in code. So we use our Spark context, we call read stream on that, passing in a format of Kafka, for example. We might then have an option of our Kafka Bootstrap servers or other options that might be available to us. And then we call load, and that's going to return a Spark data frame, which again uses that common API, right? That data frame is the same for batch as well as for streaming data. And it's just that easy, right? You essentially just do read stream as opposed to just read, and now you've got a streaming query. We can apply the transformations now. So we've read data from the table, we've called load, and now we can say, oh, let's take our value column and let's cast it as a string, and then let's cast that as JSON, right? Let's take our JSON, apply a specific schema, and unlock that JSON using that schema, and we'll just call that column data. So it's just that easy to then chain these calls together. We load the data, we apply transformations, and of course next, then we can write to a specific sink, right? So we'll call write stream, we'll say that the format is delta. Now in Databricks, that's going to be the default, but the format is going to be delta. We can add a path to a specific delta table by calling this option or applying any other options that might be available to us. And then finally, we define the trigger, right? So our trigger might be, say, 1 minute, where we load the data every minute, We apply the transformations and we write to our output sink. We then provide a checkpoint location so that we can ensure fault tolerance and exactly what's processing. And finally, we call start, and it's just that easy. So let's compare then how we might look at batch data processing and streaming data processing, right? So we have read and we have write when we're looking at batch processing. And the difference is now when we have streaming, we just do read stream and write stream. Note that many of these things are completely the same. We might add a checkpoint location, or we might add watermarks or things like that, but the API definitions are effectively exactly the same. We just have additional options that we might apply when we're working with streaming data. Let's look at the trigger types that are available to us. So we can do a fixed interval micro batch. We just call trigger and send a processing time equal to, say, 2 minutes. What this will do is it will kick off a micro batch that happens, in this case, every 2 minutes, or whatever time we specify. We also have one-time micro batch processing, but note that this has been deprecated and we don't recommend it anymore that you use this. It's been replaced with this idea of available now equals true, which allows us to trigger one time, but in this case, multiple micro batches. So rather than having a single micro batch that's processed, there's multiple micro batches, and then the query stops. We can also do continuous processing. Now, the continuous processing will attempt to process records as soon as any event is available, or as soon as data is available, and we'll keep checkpoints at the specified amount, right? 2 seconds, another checkpoint will be written, and the data will continuously be processed. What's the default? For Databricks, there's a 500 millisecond fixed interval, and for open source Apache Spark, each microbatch will be processed as soon as the previous one has been processed. Now we also have output modes. If we're doing complete output mode, then the entire result table is going to be written to the sink. The individual sink implementation is what decides how to handle writing the entire table. We also have append mode, and in this case, new rows are going to be appended to the result table since the last trigger. And then we also have update, where only new rows and the rows that are in the result table that were updated since the last trigger will be outputted to the sink. Now, the output modes that are supported does depend on the type of transformation and the sinks that are involved in the streaming query, and I invite you to click this link for more details on that.